Hey, welcome back to Tech Savara. Good to see you. You can see me, but I probably can't see you. But if you leave a comment, I'll reply. And I will not necessarily see you. I could see if you have a video on the channel that you're commenting with, then I'll see you. Well, anyway, let's get to the point. I've been wondering about, futurism and, what we could be doing with technology in the future and how, software would work. And I thought, well, let's kind of just create a bit of an example of what it would look like in, say 5 years time, right? So the idea is you wake up in the morning and you get up, you stretch, you get out of bed with your warm blanket, electrified blanket, and you hear this voice saying, "Good morning, whatever your name is, and how are you doing? I see you had a good night's sleep. I've got your coffee ready, and here is your schedule for today. Be sure to, have a quick shower and get off to work. You've got your first appointment at," etc., etc., right? That's just like what it might look like, say, in 5 years' time. I know we've kind of like seen little snippets of it in movies, and I kind of wanted to go, well, how would all that work, right? So let's go through that kind of message, like, "Good morning, you look like you've had a good night's sleep." And we've got our watches, our smart watches with which collect all of our data, and you can kind of look at how these gadgets are getting smaller and smaller. Battery life is getting better and better. So I don't sleep with this on at the moment, but I could have like a band that has like a watch that kind of that has a band with a watch on it. It's a lot thinner than this, perhaps, or maybe not. It's still maybe metal thick, but either way, the battery may last a lot longer in the time that we've got. And what that would do with that is that would collect data on your sleep patterns, and you could then use machine learning to kind of analyze what your sleep patterns are, and then based on kind of like maybe large models of data that are collected using journaling, you could then kind of go, this would indicate, this particular sleep pattern would indicate you had a good night's sleep. You could also have, say, a home pod or some kind of like camera installation that watches you and responds to you, like an Alexa kind of unit or a Google like a home Nest. And these kind of things would monitor your position in the house, your body temperature, and the the I guess the video feed would then, with the infrared data, would calculate your body temperature, would kind of look at your movements, would see that you're kind of like pepped up and alive, maybe see a smile, and that information would then again feed into a program, most likely trained, like an LLM style program that would take some feeds saying like, this is the posture. It looks like it's fast. Person is smiling. This is kind of like components that you feed into a model, and then it would spit out some text about what perhaps your mood is, right? And so for that, let's just have a think about the technology that would be required for all this. Well, let's start with the watch, right? You'd have your band, you'd have your electrical battery, you'd have a networking component, Bluetooth or other, Wi-Fi, LoRaWAN, that would then send data to like a central, maybe a home pod or a Wi-Fi, like a Wi-Fi router. Like I'm still surprised that home pods aren't Wi-Fi routers. So I have a home pod, and I kind of feel like you could replace the whole router and the whole. You got these Deco, got these router stations that can distribute a network, and I'm thinking, well, why not just put that into a home pod? You've got a router, and you got router base stations that you kind of like build out your network in. I think they had something like that. I'm sure Apple had some kind of networking system. I'm not sure what happened to it. I've got a Deco set up now, but either way, that you'd have this Wi-Fi network that then collects data. And you have like maybe a central computer, main computer, desktop machine that would then put all that together and then send it off to a secure server that would go through some calculations and quickly spit back some data. So you've got the cameras, which would collect a video feed and then do maybe on-device analysis. So it would basically maybe do some it would break down the video feed into different layers. You'd have infrared. It would then cut out, see the shape of the person. You'd have a computer that's connected like to that video feed that would then identify it as a person, get your posture, and then get some maybe semantic data, hash data that it puts together, saying this is kind of like the posture data that it's happening. And then sends that to the main computer on the Wi-Fi network, right? So there's not that much throughput happening, not a lot, right? So you don't necessarily need huge improvements in what you'd call in networking or internet networking, right? So one of the things is more kind of like security and stability is like on time, right? Speed is not necessarily that important anymore because we've got a lot of speed to send a lot of data. A lot of processing can be done on device. It doesn't necessarily need to be done on the cloud. So if I've got a video feed, you don't really want to send all that video. It doesn't make much sense, right? So that gets collated, gets sent to some machine learning model that kind of checks the data and comes back with a general consensus of your mood, other things that your schedule, and then the local machine would take that. You could possibly have an LLM locally. It doesn't really make much sense why you would want to do that, because maybe for security, but for practicality, it's kind of like file storage these days. Like so much stuff you store up in the cloud, it's not that much of a big deal. You're not sending photo data of your person up to the cloud anyway. So the models that do a lot of that you put this data through would come back and maybe even come back with the whole text prompt, which would then be read out by the local machine using like a voice generator. These days, voice generators are absolutely incredible. So you'd have like a nice voice generator. The main thing you'd want is the response time. So say you've got the schedule, right? This LLM. This text kind of has information about what's next. And if you were to ask something, well, what's next in my schedule? So Apple has like on-device analysis, and it also has on the cloud analysis. So we know that our schedule data would be on the cloud as well as locally, but to make things really quick, to get that response within, say, you'd want it to be within half a second. So you want to try and maximize the processing that you do locally. So you could do it faster, right? And you then, say if we have a schedule, we ask a question about the schedule. That question needs to be now analyzed. It needs to be sent through. It would be put through another model with your context window of the schedule, right? And then you'd get that back. Now, one of the things I guess you could say is like you have your phone. If you're talking to a general entity, right? We'll call it Siri, right? Because I use Apple devices. Say we're talking to Siri. You don't necessarily always. You might ask, well, what's the weather going to be like today? One of the things I always do very often is I check the weather, right? So I've got a weather website, and I do that because if I want to go for a run, I want to see if there is rain, if it's raining right now, and if it'll rain in 5 minutes. So I might actually go. It's like, hey Siri, is it going to be raining in the next 20 minutes? I want to go for a run. Now, BOM's Bureau of Meteorology, they have like a radar map, right? So there's that radar map I can look at only on my phone, right? So, and the way you would calculate it is you would calculate the distance from what the radar shows as the rain map, like it shows you where the rain is, and what time that would get to where I am. Now, I could probably do that now, right? I could probably say if it's going to be raining in 5-10 minutes. I could look at the rain radar, I could look at the trajectory of the rain, but then, you're never 100%, so you could always have like an error. So it's like the response would be something like, if it looks like it's going to rain today, are rain clouds heading towards you, right? So we know that there's rain clouds heading towards my general location, GPS or other positioning systems. There are competitors now appearing to GPS, but we have our GPS, we'd have our radar, we have this data set that happens on the Bureau of Meteorology's site. Now, we would have an application that kind of integrates this maybe locally. Like on my phone, I have the app. I would have that as a running application, an ambient application, you could say, that would take an intent. So apps have now intents a lot of the time where you supply some information, it can give it back to you. And Siri, you can feed Siri intents. Now, these kind of things have been around for 5 years already. So it's not like that hasn't been around, but I guess the voice part hasn't been. So the question is like, well, what do you do with that data? I mean, that's the future. I mean, that's what we're building now. So, that's a quick introduction as to what we could possibly see in the next 5 years. So I will catch you at the next video. Bye.